So here we have an example, a very basic test, and here's what we would have done on the previous slide. So we have our test class, we have our method, or annotated with test method. Another thing to point out about your test methods is because they're being called by the system, your test methods will never have any parameters, nor will your test methods return anything. Because the testing framework wouldn't know what to pass to it, and the testing framework wouldn't know what to do with what you returned. So the return type is always void, and your test methods never have parameters. Now, what we do within on line 4, we create our candidate, we insert it into the database. That would then fire off our trigger. We're then going to query the database to find out, did we successfully, in creating a candidate, did our trigger successfully create that contact, okay? And so we're going to do an assertion that we, let's say we properly populated the first name fields from our mock data right here. So the negative code path, in this case, we don't have any exception handling logic in our trigger, okay? Normally, what we're doing with our negative path tests is making sure that if we have a situation that can occur, like, you know, a user doesn't fill out a field, would be a classic one, that we gracefully handle that and we return an error message, which is, you know, human readable, indicating to them that they need to, you know, populate that field, okay? In our case, our trigger does not have any exception handling logic. So we're just checking to see that on, you know, if we do not populate the last name, so in a contact, the last name is a required field. So if we simply created a candidate with a first name and inserted it, the insertion of the candidate would succeed. But the trigger inserting the contact would fail because that's a required field on the contact. And so here we're just checking to see that we, you know, receive the proper exception. You would probably want to have some exception handling logic and then make sure, like, let's say you're adding a message to the Visualforce page or returning, you know, like I said, returning some sort of message to the end user, make sure that that message was returned, okay? That you gracefully handled it. The ways that we can initiate our tests, right now you can execute, there's actually, this is something that needs to be updated here. All of your tests, I guess you could say that the Force.com IDE is running them synchronously in the sense that you're waiting for the result. But these days, all of your tests are going to be run asynchronously. So for instance, when you go into the developer console and you kick off your tests, you'll see that it has the logic to just run that in the background, and it has a nice little, you know, circular waiting icon, okay? But the reason we do that is that one of the things that we don't want to occur is we don't want the test, let's say you're running all of your tests, and they take longer than your browser timeout, okay? So we've done that so that just because your browser times out because it hasn't received a response, we don't want to miss those results. And then also, your tests are executed automatically during the deployment into production. When you're creating your tests or running your tests, you can either, in the Force.com IDE, and this is what we're looking at right here, you could either right-click on a specific class, or you could right-click on the classes folder. If you right-click on the classes folder, you will run all of your tests. If you right-click on a specific class, you are running all of the tests in that class. You cannot go more granular than that. You cannot right-click, for instance, on a specific method and run only that test. So it's actually something that you might want to do, which is to have a one-to-one correlation between a test method and its own test class for the purpose of being able to run at a granular basis one specific test. It's your decision. The drawback to that is you're going to end up with a lot of classes, and then it might clutter things up. All right, the test results. So after you run your test, you're going to get back results. And so one of the key things that you will see, so for instance here, if we didn't have, if our add candidate trigger was not working properly, we would see our result here indicating what line and what exactly happened. You'll also see the code coverage. So one of the cool things is that you can actually click on the results and see what lines were executed and what lines were not. So in this case, when you're running your tests, you can go back and see the classes that you executed and then click on those classes. You can also see the statistics down here, the 55% out of 75%. Supplying test data. All right. It is possible to create tests that have access to pre-existing data. So one of the things that you could do is you could create a test that is going to get its mock data from the database. You create a SOQL query, so instead of doing a new candidate, instead you're going to fetch an existing candidate from the database. This is not recommended, and the reason this is not recommended is that let's say you're in a config only or a developer sandbox. Well, we don't copy over the data to those environments. So by default, unless you created mock data, your test is going to fail. The second thing is by fetching records from the database, you're creating tests which might, depending upon which record they found in the database, they might succeed in some cases and then fail in others. So for instance, we might have candidates that don't have last names. The problem we have here is that we maybe click on the run test once, it fetches a candidate that does have a last name and it looks great. And then in the next example, we fetch a candidate that does not have a last name. Now suddenly it looks like our code broke. It's not our code, it's our data. Okay? So it is highly recommended that you utilize mock data. There are two ways that we can work with mock data. So we can either work with mock data by loading it in from a file, or we can load it in via, or we can programmatically generate mock data. So if you wanted to fetch data from the database in order to generate your mock data, there is an attribute you would need to apply to your isTest annotation. And what it is see all data equals true. And what it does is it opens up the database within the context of running this test to see the existing records within the database. Just so you know, by default, you will see things like profiles, users. You do not, even if see all data equals false, you will always see users, you will always see things like profiles. So there are a few things that you will see which are not really metadata per se. This should only be used in special circumstances when the test data cannot be created. And then, as I mentioned, the drawbacks are you don't want inconsistent org-dependent tests. A better thing to do would be to create your own mock data. And one way that we can do this is we can create a CSV file. We can then upload that file into static resources. Okay, so we might, maybe we export via data loader. We then create our mock data, make sure it's all fine and good. And then we can load that back into static resources, which is under the develop menu, typically used for static content associated with our Visualforce pages. Then what we can do is there is a test.load data, and what you're going to do is you're going to specify the object type using this notation. So in this case, it's going to be candidate:\c.sObjectType. And then the second argument is the name of the static resource that is the CSV file. Okay? So when we would have uploaded this CSV file into static resources, we would have called it test candidates, and now we refer to it by its name. What this will do is it will take the CSV file, parse it, and then it will deserialize it into, in this case, our list of S objects which are candidates. Okay. A second option that you can do, you can programmatically generate your mock data. Now, you're going to want to create reusable test factories, okay? And so one of the things that we would recommend is create a public class with the isTest annotation, then create public methods. Now, because these public methods are contained within an isTest annotated class, these methods can only be called within the context of running your test. But what you would do is you would call something like this, build test candidates. Notice here what we've done, integer I. You want to make your test logic, your test factories bulk ready, because frequently, just from the get-go, always do this. You could either do something like this, where maybe the for loop exists outside of the factory method, and you're iterating over this and creating, let's say 200 test candidates. Or you could do something like a different architecture, which is to return a list of candidates, and you pass the number that you want to generate. However it is that you want to do this, build your test factory methods to work in bulk always. There's no need to create singletons. All right, testing bulk operations with multiple users. All right. As I said, you want to verify that your code is bulk ready, okay? So you want to, especially when you're working with triggers, you want to execute your triggers by working not with one record, but by working with up to 200 records, right? In that way, we're executing our trigger code with many records, not just one, and really, truly testing their capabilities. Well, wait a minute. Let's say I do 30 DML operations in my initialization logic, and let's say I do 30 SOQL queries. I'm not really testing against 100 SOQL queries. I'm testing against 70 because I already burned through 30 of them in my verification logic to fetch the data, okay? So we can actually do something about that. There are a couple of methods that are available to you, test.startTest and test.stopTest. When you surround, so remember we had our the three areas of a test. When we perform our initialization logic, we can separate the governor resource utilization of doing that and also our verification logic for querying the database and so on by using the start test and stop test and surrounding the portion of our test that calls the targeted business logic. So essentially what this does is you get two sets of governor resources. There's one count associated with the initialization and verification, count A, and then there's a second count associated with executing your targeted business logic. So now, in calling update my test data, we're actually counting, we're checking to see, are we operating within the constraints of 100 SOQL queries, not however many fewer because of what our other logic was doing, okay? So that is the mechanism that you can do. Just so you know, in a single test method, you can only call start test and stop test once. You can't call them multiple times. System.runAs. This is another method, even though it's in the system class, it can only be used within the context of running a test. And what this gives you the ability to do is it gives you the ability to run code as some other user. So the problem with you, the system administrator, who has view all data, modify all data, you're a super user. The problem with you running the code as you is you're not properly testing visibility of things like with sharing. If you have some logic that, based on the assignment of a record, to a, let's say a queue, we want to verify that we're not doing this as a system administrator. We want to verify that we're doing this as one of our sales reps, let's say, with their profile and their roles and so on and so forth. So what system.run as is you surround your code with this block, and then what you do is you basically pass a user ID of a user that you want to run this code as, and then when you're, for instance, initializing your test data, you've initialized it as that user as opposed to yourself. Okay? Let's do a quiz question. So, module review. What percentage of Apex statements must be tested, and then when we deploy to production? Well, it's 75% of your lines across the org, but you must execute 100% of your triggers. Not the lines, but at least one line in every trigger must be executed. Okay? All right. Assume you have a test case in which you compare two integers. Which assert methods would you use to cause your code to stop executing if the two integers were the same value? Yeah, very good. You're correct. So in this case, we want to be notified if they're the same value, or if they are the same value. That is a bad thing. Therefore, we would use not equals. Okay, very good. Which two reserved words can be used to indicate that a method is a test?
Is test annotation or the test method keyword?
Very good. We recommend that you use test method for your methods, just for the purpose of visually, if you reserve is test for the class and test method for the method, visually it's a little bit, it's an indicator, a little bit easier to read your code, but it really doesn't matter. How can you ensure that your test code won't count towards your code size limits?
With the test code in class?
Yeah, and how do we mark that class?
IsTest?
Yeah, so we mark a class with the isTest annotation, and now that will not count. Which annotation, I think we only have one. All right, which annotation needs to be set to true for SOQL queries to return pre-existing data? Actually, this question is misphrased. Which attribute needs to be set to true for SOQL queries to return pre-existing data to your... See all data, exactly. So between using a SOQL query and a static resource to initialize test data, which method is preferable and why?
Specify mock data and using Apex statement.
Exactly, yeah. So utilize the mock data, and the reason is that we create universal tests that will be more consistent. Okay. What do test.start test and test.stop test help you do?
They give you two ways, two sets of governor resources, and also one is for initialization and the other is for executing business logic.
Exactly. So when we're testing the bulk readiness of our code, we get two separate allocations of resources, and that way we're doing a pure test of the utilization of our resources.